You are welcome to the Scholar Online class.
The Scholar School, we establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
You're welcome to the Scholar Online class. My name is Mr. Abdulwasi Abdurrahim. I will be your mathematics teacher for today, and I'll be taking you differentiation. And what we'll be looking at in the differentiation are introduction to differentiation, concept of limits, differentiation from first principle, differentiation from formula, that is the general rule of differentiation, differentiation of monomial, binomials, and polynomials, then differentiation formula and application of differentiation. Now, to start with, when we talk about differentiation, the concept of differentiation has to do with the concept of limits. Before you can differentiate variables, it means you have two things, which are the x and y. Just like you have, let's say you have y is equals to 2x. From this equation, y is one variable and x is another variable. The two are related together. So the y depends on x. So y is called dependent variables, while x is called independent variables. So anytime we talk about differentiation, it means we are evaluating two variables side by side. Now, differentiation is an aspect of mathematics that has to do with what? The change in one variable with respect to what? To another variable. For example, when you talk about change in price with respect to what? Quantity, or change in supply with respect to quantity, and so on and so forth. So let's now look at the concept of limit. That was the first aspect. Concept of limit. Now, when you talk about the concept of limit, for example, let's say we have f of x. This is called f of x, or we can also call it y. So if you say f of x is equals to 2x squared plus 3x plus 4. Now, it means that all this y depends on what? All these variables. So here, the only constant variable is what? Is the 4. Now, under the concept of limit, we limit this x to a particular value. That is, we have f of x equals to 2x squared plus 3x plus 4. Now, if our x tends to 0, what this means that what? As x is approaching 0, these values here will also be approaching a particular constant. That is, when s approaches 0, then it means that anywhere you see x, you put 0 there. Which means it will now give us the limit f of x to give us what? A particular value. Likewise, our s can also tend to what? Tend to 1 or minus 1. That means well, when x is 1, you put the values here. Likewise, our s can tend to what? Infinity. Now, when s tends to infinity, it means that that value which you can what? You cannot determine the end. That's what we call infinity. So, under the concept of limit here, we have three things we'll be looking at. We'll be looking at the linear limit, and we'll be looking at what? The fractional limit. The fractional limits are divided into two. The first one is when the numerator, the power of the numerator is greater than the denominator, and the second is when the power of the denominator is greater than the numerator. So starting with the first one, I have function f of x, that is equals to x squared plus 3x minus 5. Then you have lim. This is limits. So in writing our limits, we have two ways of writing it. Is that I write it as what? Lim. Or I just use the first and the last letter, LT. These two means limits of a function. So if I want to write this, if I say lim x tends to, let's say 1, it means that in this my function here, anywhere I see x, I will replace it what? With 1. So that means I have f into 1 is equals to 1 raised to power 2 plus 3 into 1 minus 5. And that'll give me 1 squared is 1 plus 3 times 1, 3 minus 5, which will give us 4 minus 5, and that results into minus 1. That is the meaning of that limit, which is the linear limit. Likewise, I can have in another scenario. This is example 1. Let's say we have another one. F of x lim x tends to infinity of what? Let's say x squared minus 2 into x squared minus 4. The same thing is applicable here. We have two approaches here. Is either we substitute the infinity into the formula as our x tends to infinity, or we expand this expression. Now, following the first part, we have f of x is equals to, this one is x squared. So we have x squared minus 2 because it's not factorizable. Why this one is factorizable? This is different of 2 squares. There you have x minus 2 into x plus 2. This is what we call difference of 2 squares. That's x squared minus 2 squared. So then we can now substitute our infinity there. So when x tends to infinity, as x tends to infinity, it means anywhere I see x, I'll put infinity there. That means you have infinity raised to power 2 minus 2 into infinity minus 2 into infinity plus 2. Now when you say something tends to infinity, it means what? It tends to what? An end in which what? We cannot determine what is there. So in most of the instances, we take it as what? As 0. So and our answer here will be minus 2 into minus 2 into plus 2. So when we multiply, minus times minus will give us plus. 2 times 2, 4. 2 times 4, 8. So that explains the first aspect, which is what? Linear limits. Let's now look at the second aspect, which is what? Fractional limits. Now, when you are talking about the fractional limit here, remember I said we have two types, or we are looking at two scenarios here. The first one, let's say you have f of x is equals to x squared minus 3x minus 2 divided by x minus 1, or let's say x squared minus 1. Now, in this case, our x tends to 1. X tends to 1. In this case, you cannot substitute directly into this. The reason being that if you look at the denominator here, x squared minus 1, the interpretation is same as x squared minus 1 squared. And this is different of 2 squares, which can be expressed as x minus 1 into x plus 1. So when you substitute x is equals to 1 here, automatically this one becomes 1 minus 1 into 1 plus 1. And 1 minus 1 will give us 0. If 0 multiplied by anything will give us 0. And ideally, you are not supposed to have 0 at the denominator. Because when you have 0 at the denominator, we call it what? Undefined expression. Which means what? You cannot proceed to solve that problem. So that's the reason why we cannot substitute directly into this expression. So the first thing we need to do is what? To factorize the expression. By what? Looking at the numerator and the denominator. So if you look at the numerator here, to factorize that, x squared minus 3x minus 2. Factorization is what? Breaking this expression into what? Into 4 entities. We have 3 here, we want to break it into 4. So what will be the factor? We want to change this middle one to something that will give us this last one. So let's change it to plus. So it means that two numbers that when you multiply together, it will give us plus 2. When you add the two numbers together, it will give us minus 3. And the numbers are what? 1 and 2. Now, since the sign that we have at the middle here is negative, the two numbers will carry negative sign. So that minus 1 minus 2 will give minus 3. Minus times minus will give us plus. 1 times 2 will give us what? Plus 2. So I will replace this minus 3 with what? Minus 1 and minus 2. So that means I have x squared minus 1x minus 2x plus 2. Then we group them. Since they are 4 now, we group them into 2, 2. So for the first grouping, what they have in common? X. So we have x into bracket x minus 1. Whatever you have in the first bracket must repeat itself in the second bracket. Just open your bracket again, repeat again, x minus 1. What this one have in common? That is 2 minus 2. Let's open the bracket. Minus 2 times x minus 2x. Minus times minus plus 2 times 1, 2. You can see that is the same. So since what we have in the same bracket are the same, you pick one and group what you have outside the bracket. So therefore we have x minus 2 into x minus 1 will be our numerator. So we now go back to this now. So following what we have here, so limit x tends to 1. This means we are going to have what? Our factorization there, x minus 2 into x minus 1 divided by this one also factorize x plus 1 into x minus 1. So if you look at it here, you see that was something we cancel out. Something we will definitely cancel out. And what is cancel out? X minus 1 cancel out. Remaining x minus 2 over x plus. So therefore, I have my f of x, lim x tends to 1 is equals to x minus 2 over x plus 1. Then you cannot substitute now. So when x is 1, anywhere you see x, put 1 there. That means I have 1 minus 2 divided by 1 plus 1. That gives me 1 minus 2 give us what? Minus 1 over 1 plus 2, 1, 2. That's our answer. That is the first aspect of the fractional limits. Now, the second aspect, you can see that this is straightforward because we can factorize both the numerator and the denominator. In another context, let's say we have f of x is equals to 3x raised to the power 2 minus 4s plus 5 divided by x squared, or let's say x plus 3. X plus 3. Lim x tends to minus 3. Just like I said earlier, you cannot substitute this minus 3 here. Because when you put minus 3, it will be minus 3 plus 3. That will give us what? 0. And I say you are not supposed to have what? 0 at the denominator. So what you do is what? You look at the expression that we have here. Is the numerator factorizable? 3 times 5, 15. And we have minus 4 at the middle here. So what are you going to do? That will give us minus 4. So if you look at 15 here, that's 5 and 3. So there's no another number except 5 and 3. So 5 plus 3 will give us 8. And 5 minus 3 will give us what? Minus 2. So the expression is not factorizable. So under this context, when the expression is not factorizable, and when you substitute it's going to give us 0, then you do what? You divide all through by the highest power of x. So what I'm saying in essence is that since this, when you substitute this, is going to give us 0. And when you substitute this directly here, and this one is not factorizable. So how do you now solve it now? In this context now, you divide both the numerator and denominator by what? By x. All through. That means I'm going to have 3x squared over x minus 4x over x plus 5 over x divided by what? X over x, then plus 3 over x. That is what you are going to do in this context. And that will result in what? 3x for the first one minus 4 over x plus 5. Okay, minus 4 because the x will cancel x. Then plus 5 over x divided by 1 plus 3 over x. 1 plus 3 over x. So if you follow this through, anywhere you see x now, if you put 3 there, this one will still go back to the initial stage. So let's divide all through by x squared. X squared over x squared over x squared. And that translates to what? So this one will remain in 3 minus 4 over x plus 5 over x squared divided by, this one will give us 1 over x plus 3 over x squared. Lim x tends to what? Minus 3. Then we can now substitute now. So when x is minus 3, anywhere we see x, put minus 3 there. That gives us 3 minus 4 over minus 3 plus 5 over minus 3 all squared divided by 1 over minus 3 plus 3 over minus 3 all squared. And that translates to 3 plus minus divided by minus will give us 4 over 3 plus 5 over 9 divided by minus 1 over 3 then plus 3 over 9, which translates to, so I have f of x. This one translates to what? I have 3, 9, 3. So the LCM is 9. So if you multiply all through by 9, this will give me 9 times 3, 27, plus 3 times 4, 12, plus 5, divided by 9. Then we have the long division. This one here, the LCM is also what? 9. So 9 and 3, this will give us minus 3 plus 3 all over 9 by taking the LCM. That is 3 in 9, 3. 3 times minus 1 minus 2, then 9 cancel this. So this will now give us 27 plus 12, that is 39. 39 plus 5 will give us 44 over 9 divided by 0 over 9. I hope I'm with you. I hope you are with me. 3 plus 3 minus 3 will give us 0, then over 9. So this will give us 44 over 9. Because 0 divided by any number will give us 0. So answer will be what? 44 over 9. Then the last aspect I want us to look at under the limits is when our x now tends to infinity. So when our x tends to infinity, what you do there is just also the same thing I have done here. We divide all through. Assuming we have x squared plus 3s plus 1 divided by x squared minus 3x minus 2. Limit x tends to infinity. Limit x tends to infinity. Now, in this context here, you see that the power of the numerator and denominator, the highest power are the same. So what you do here is you divide all through by the highest power of x. And the highest power is what? X squared. So this one is going to give us x squared over x squared plus 3x over x squared plus 1 over x squared all over x squared over x squared minus 3x over x squared minus 2 over x squared. And that results into this cancelled, that's 1 plus x cancelled, where you have 3 over x plus 1 over x squared divided by this cancelled is we have 1 minus 3 over x, 1x cancel 1x then minus 2 over x squared. So as limit of x tends to infinity, just like I explained it earlier, infinity means what? An end which you cannot approach. And we always take it to, we always assume it as what? As 0. So that means I'm going to have 1 plus 3 over infinity plus 1 over infinity squared divided by 1 minus 3 over infinity minus 2 over infinity squared. And since we say infinity, we take it as 0, it means our answer is going to be 1 over 1, which is what? 1. So this is the concept of limits.
This is just the beginning. Don't miss the next episode. Thank you.